Hello, my name is Jemmy, and today I am going to be giving you a brief overview on what happened on week 6, basically a week 6 update. And then, yeah. So, first thing is that when I opened Colab today, there's actually these like little uh, cats and dogs running, which is actually pretty normal, but then the cats and dogs are really different. I don't know why, but they're like this, and like it's like purpley cats and like cats with like cake on their like uh sides. Yeah. And then there's dogs with the hearts running around like this guy. I don't know why. What is this even? This like so weird. And yeah. So that is a good surprise, I guess, because normally it would just be like normal dogs and cats, but it's like weird now. So yeah, that's just one thing I just saw. But other than that, what I also saw was I was experimenting with augmentation for my foodie duty since I'm actually almost done with my model. I just need to optimize the not the error rate, to be as low as possible. So I experimented with augmentation, and today I'll just show you how that goes. First, you gotta understand what augmentation is. So down here in the data block, there is two main things for augmentation, or really just two things that augments it. Not one thing that augments it, and the other is just resize. So this is called batch transform, augment transform. So this will basically just like tilt our image or like squish it, not squish it, like tilt it, twist it, uh, make it like rotate it or like make it brighter or warped or something. And yeah, that's what it does. Or it could just even size that image to how much pixels, and it'll do the augmentation from there, or that resolution. So yeah, that is augmentation. And then for item transform, I will also be using this. So item transform is just pretty simple. It's just gonna resize our image, and with three methods, either squish, or pad, or crop. And yeah, I'll explain each three later on in the video. But yeah, that is augmentation. And let's go into slides. Okay, let me go to the first one. Okay, perfect. So here is week 6 update. So I'm gonna give you a really, not quick, but yeah, an update on what happened. So ignore the faces. I didn't really mean to put that there. I just was bored and I just put it there by myself. So yeah, basically, this is what my experiment chart for augmentation. So as you can see, there is several augmentation. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's 20 in total, and I ran them at 10 epoch. The first one I just ran at 15 because obviously it was going to be bad because it has no augmentation. So I ran at 15, but the rest I ran it all at 10 epochs, or 10 fine tunes. And so let's look at the first one. So the thing that matters to me is the error rate, because that's the thing we're gonna base it off. It's our metric. So if the lower the error rate, the better it is. So at none, meaning no augmentation at all, the error rate sits at around 6.6%, which is actually decent. It's better than ResNet 18 that I got, which is 8%. For resizing, well, doing augmentation at size 224 pixels by 224 pixels, it got an error rate of 5.9, which is better than no augmentation at all. And it's pretty better. But then something I realized, it's the train loss just dropped, not dropped, but increased by 5 times. I don't know what that does, but yeah, I don't really know what the train loss is. I just care about the error rate, but I just noticed that. Maybe it's better. So yeah, that is train loss and error rate. So the error rate is better, and then size 512 pixels. It's actually the best one out of everything in here. It rests at in 2.8% error rate, which is really good, almost to like 2%, which is very close to 1%. And yeah, that is very good. Also, it is the best one in here, so yeah. And then let's move on to do flip. So it's just gonna flip it, and it got 5%. Flip vertical, it got 5.4%. Rotating 10 degrees is around 5.6%, and rotating 20 degrees is 5.4, and rotating it 30% is 5.6. So yeah, and then rotating it 45% gets us to lowest out of them all is 5%. And max zoom, this is just to zoom in on the image, 1.5 is how much? 5.1%. And max zoom 2, so it zooms in 2 times, is 3.9%. And oh, this is, by the way, the second best one, right after size 512. So zoom is after 512. And then max zoom is 4.7%. 3, max zoom 3. And then max lighting 0.1 is just to increase the brightness, is at 5.8%, and max lighting 0.3 increases by 0.3 is at 5.5%. Max lighting 0.5 is at 5.2%, and max lighting 0.7 is at 5.8%. Now we're gonna move on to our last augmentation, which is warp. Warp just makes the image like warped, if you know what I mean. It's like distorted kind of. And then it's warp 0.1 equals to 5.5%. Warp 0.3 equals to 5.9. Warp 0.5 is equal to 5%, and warp 0.7 is equal to around 6.8%. So the best one out of there of them all is 2.8% for size equals to 512 pixels by 512 pixels, and the second best is the zoom times 2, and yeah, that is the two that stands out, because the rest is just sits around at 5 or 4 or 6, and to 4 to 6. But the two that stands out is the 512 pixels and zoom times 2. So yeah, that is the two that stands out, and that is my experiment chart. Okay, so then I got the idea to combine the two best ones, which is zoom times 2 and 512 pixels. So I decided to combine both of them, and I want to see the result, because my theory was if you combine two that were good, it would make a better result. However, it kind of did, it kind of didn't do that. So if you look at the error rate at the end, it is at it is resting at 3%, which is better than zoom times 2, but it is worse than 512 pixels. So then I decided that I'll just use I'll add one more just to see, experiment. And then so I added lighting 0.5 because I noticed that some pictures were a bit too dark. And then the results was here I'm going to choose Epoch 7 because it's at the best. So it is at 3.3%, which if we go back here, it is better than zoom equals to 2, which is at 3.9, but it is worse than zoom plus 512 pixels. So that didn't really work out either. So I decided to just stick with 512 pixels. So I ran 512 pixels again one more time, and the result was even better. Instead of having a 2.8, it dropped to 0.1%, and it got to 2.7% and error rate. So it was looking pretty good. And then I ran the confusion matrix, and it looked pretty solid to me. All dark colors, mostly 30 or 29 to 25. I don't even think there's a 25 in here. Yeah, there's no 25 because it's so accurate. It's 25 above, or I should say 26 above. Actually 25 above, because yeah. So there's only 26 to 30, and that's it for my confusion matrix, which is actually pretty accurate. And yeah, so now I went and ran the top loss. So here it is. It predicts it's 0 0, which is a menu, and then it got something else. So yeah, it's pretty accurate. And at the end, there's not too much that's wrong if you look at the bottom. Yeah, so that is my top loss. And I noticed some things on my top loss. It's pretty reasonable. There was shrimp fried rice, but it guessed it as fried rice, and I thought that that was okay because both of them are very similar with each other. So yeah, I accept that. But there's some that kind of doesn't make sense. However, it still has something to correlate with each other, like musate, which is a Thai pork thingy that is yellow, and omelette. So both of them are yellow, and it guessed the musate as omelette, and yeah, so both of them are yellow, so I guess that's okay too. Not really, but yeah, whatever. But because it's still there, and I'll show you it later on. But in the confusion matrix, it just shows that the pork was actually the omelette, but it's both yellow. I mean, so it has a reason behind each one. So yeah, that's my experiment. However, I'm not done there. I was a little too lazy to put it on the slides, so I have it in my Notion or my notes, and I'll show you it. So from here, what I did was I experimented with item transform. So yeah, so item transform is just to resize your image, and so that's what I did. So I did, and this is because when I do aug transform, it resizes my image to 512, but it still does augmentation on it, which means it still like twist it or like turn it, rotate it. So that's why I was experimenting with item transform with augmentation. So here I did augmentation with item transform, so aug trans and item trans, and the results were at 3.3 or 3.3% error rate, which was decent, but it was still worse than only augmentation 512. So I thought, hey, I'll just run 512 pixels augmentation again, just to see if the results were like steady at like 2.8, 2.7. However, it was pretty I was pretty surprised. It was at 3.2%, which is still better than augment transform with item trans, but it was worse than our results by 0.4%. So it got me a little worried. And so so then I was really worried about this, and then I decided to run it one more time, but I don't think I have it in my notes, and it even got a worse result. So I was pretty scared, but then I ran it one more time and it got better one. So I just saw it kind of like stayed at 3.4 to 2.8 around ish. So that's like where it averages, and it's actually pretty good. So yeah, continuing from here though, this is this right here is my right here, this is my okay, I don't know really how to explain this, but if you look into the fast AI documents, there is, oh wait, this is item trends. Yeah, this is item trends, sorry. There is 3 ways to do it, as I said in the beginning of the video. There is the method squish, pad, and crop. So in here I did squish, and the best error rate, or no, I only did 1 epoch on all of them, and then squish's epoch was 17%, and then that was the best out of them all. The second best was crop at 17.9%, which was 0.9% worse than squish. And then the last percent, which is the worst one, is pad, and pad got us to 118%. I'll tell you what all of them does. So squish is just like if your image's dimensions are like a rectangle, right? And then it we set it to 512 pixels by 512 pixels. It will squish it into a square. It doesn't care what the image will look like. It just like stretches it and then or like squishes it and makes it into that shape. And pad, it just puts like a dark like two or more um actually one or more dark lines onto like to make it into that shape. So it puts like black bars on our images. And crop, it just crops our images, crops our image like into a square, and then it'll just resize it into 512 pixels. And yeah, those are the three methods. And since squish was the best, I decided to run it 10 times, and I got the result in here. It was not too great, because the best result was 3.9%. I mean, it was decent, but it was not good. So I didn't use that anymore. So in here, I had to do a test result. This might be a little confusing, but usually with the confusion matrix, it is only on with how do you call it? It is only with valid set, and valid set you can run it multiple times, which gets a better result. But if you test it with the test set, you can only run it one time, which means that if it doesn't get a better result, it can only run it once, meaning since our model is already trained, we will just test it. And then at first I got a really bad result. Like one of them was even to 17, and a lot of them got wrong because because my images that I tested them with was 224 pixels by 224 pixels, not 5112 pixels. So if you want your images to be like, when you test your image, you want it to be correct, then your test set needs to have the same resolution as your train set, or the thing that you want to train your model with. So here is how much I got for a test set. At first it was really bad, I told you, but then I resized all of my test set images to 512 pixels by 512 pixels, and then this is the result. Pretty good. It's actually the lowest one I see here is a 27. There's 427s in total, which is better than valid actually. 427s, and yeah, that is my test set testing, I can say. And then here is our classification report of our test set, and then I used this code with it. I can explain to you kind of ishy. So F1 score is times precision divided by recall plus precision, and then precision, I'm pretty sure, is how much is actually there, and how much it got correct, and recall is how much it guessed it, and how much was correct from the guesses. And then yeah, F1 scores those two times each other. I cannot be too accurate with it, but yeah, that is my brief overview on week 6. Okay, I forgot to change this. Week 6, there we go. And yeah, that is week 6. Actually, I want to show you my binder too. This is my web app deployment thingy. So I'll just show you it really quickly. It will load a long time, so wait. But then yeah, I pushed my images and everything, my new test set, or like my new code into GitHub, and yeah, so I pushed into my binder, not push, well, I just made my binder just do its thing, and then now I'm just going to show you, but it takes a few minutes, so I'll see you when it's done. So we are done. My binder's done loading. So here is the menu chart. It's in Thai, but what it says is just shoes the menu in here, one of the menus, and get the image, and then you can test it. And here it says for us to choose the image that we want, which means you click this button and then just choose an image. I will grab from my downloads. Here it is. There. So this one it is called Tom Yum Kung, and it is number 27. So if it shows up, there we go. Tom Yum Kung 99.999%, which is actually really good. And then the second one is Gang Som Kung, which is shrimp, orange shrimp soup. And then this one is Tom Yum Kung, which is spicy shrimp prawn something, but I don't remember the English name. But yeah, all of them are really similar, and all of them have to do with shrimp. Like, look at this one, shrimp. This is actually roasted. Well, not roast. I think it's roasted river shrimp. Well, that's what it reads. If you translate it directly, then that's what it is. And then this one is something about shrimp too, and then this one's shrimp too. So all the top 3 guesses are on shrimp, and yeah, it's pretty accurate. This is my poster on it. River prawn spicy soup. That's what Tom Yum Kung is. River prawn spicy soup. And then the ingredients are shrimp stock, shrimp, kaffir lime leaves, and all these stuff. And it has 873 kilocalories per bowl, and the spiciness is at full max. And yeah, that is my shrimp. Not my shrimp. That is my my Binder web app of Foodie Duty. Yeah, I hope you enjoyed this video. Goodbye.